and now I will be explaining the rules which you should take note before designing a PCB, or before you manufacture the PCB, and some of the assembling capabilities. So the website name is JLCPCB.com. Here you can find the rules which you should take note before designing a PCB. Here are certain features or certain parts of the PCB which you should know that those are important, and while you may add into your PCB. So here are some PCB specifications, like how many layers are using for the PCB, what is the control, what you want to make an impedance, or you want an impedance tolerance, which material you are using, the dielectric constant of FR4 material, which is so common, and these material are used in industrial in which they manufacture the PCB, and those the maximum dimensions which you will use while designing the PCB, the height of your PCB board. For me, the board which I had designed, its height is 1.6 mm, and these are the layers and the copper which you will be using, which are basically 1 or 2 ohms of copper. So these are my the PCB specifications. So there are 1 to 32 layers of the PCB, in which 1 to 4 are the layers which is commonly used in a small level of manufacturing, and after 4 there it comes 6 to 32 layers, which is so precision accurate, and it's so powerful. So my board has 4 layers. So basically there are 2 power layers, and there are 2 ground layers. The first two power layers are top. The layer 1 and layer 4 are my power layers, and the layer 2 and layer 3 is my ground. And so hence that's all for my PCB specifications. And there are also the drilling rules which you should take note. So as you can see, the drill diameter, the hole size, tolerance, and and so on. Now also there are the traces rules. It means that how much width you should take while making a trace. So there is also a website which you can calculate the width of a trace. It's known as a PCB way, in which you can calculate the impedance calculator, or you may want to find the trace width. It should, like if you are using the 1 mm tracing, it would be so big, so you don't want that, right? So here is a trace width which it will decide that what trace width should be perfect for your PCB. So our track impedance should be 50 ohm. It is common. The people commonly use the 50 ohm as a track impedance. Our trace this is the industrial standard for high speed signals, and such as USBs, HDMIs, RFs. And now we will move on to the trace thickness, which is 1 ounce or 2 ounce. So I have used the 1 ounce of copper. And the height of the PCB, as I have mentioned earlier, that I have height of 1.6 mm, and the dielectric constant ER, which is around 4.3, I guess. So yeah, 4.3, right? So as you can see, it basically calculated our the trace width, which is 2.9852. Yeah. So this is the formula which basically puts our value in this, and the trace is calculated out to be 2.9825, which you can use this in your PCB designing. Now let's move to the PCB designing on easy EDA, and that I will be explaining the differential pair routing, equivalent tuning. Yeah, thanks.